Okay guys, so today we're still on differentiation, but we I'm going to be looking specifically of differentiating ln functions, right? So remember from when we did logarithms, we know that ln is a log function with base e, right? So we're going to look at differentiating ln functions. So for example, so the rule is if we have y is equal to ln of some function here, f of x, the differential of it, dy dx, would be equal to, now this f dash x means the differential of f of x, right? So this is just an x notation for it, I think, right? So you guys that, if not, well, we're doing it now, right? So f dash means you're differentiating this part here, whatever function is, you're differentiated and you're writing that on top, and underneath you're just writing back whatever the function was. Okay, so this is a simple example, so I'm gonna kind of like, okay, so we have this function here, right? And we need to find dy dx. So the first thing is you let the function be, so you let y equal to ln f of x, right? So just by comparing it now, we see that f of x is this part here, right? So that means that f of x is equal to the part in brackets, basically, right? Right. So in order to get this, we need to, they say you need to get f dash x, right? Now f dash x is just when you differentiate this, so we're going to work out f dash x. And we know we could use the shortcut chain rule here, right? Okay. So with the shortcut chain rule, we'll throw the 3 in front, minus 2x, and we'll reduce this by 1, so that will give us 2, and then we multiply by whatever the differential inside here is. This will be 0, this will be negative 2. So to finish that up, 3 2s are 6, so it will be negative 6, 1 minus 2x squared, right? So we get f dash x. Right, so when you reach here, there's it, you just go and put your answer in order now. So dy dx would be, we're using this, right? F dash x is this big expression we have, 1 minus 2x squared over f of x. You remember f of x was this here, 1 minus 2x squared, and that's it, and you're done. I mean, it's something new, something you have to get used to, you have to practice, and you'll get through it, but it's nothing difficult, right? So let's do another example. This one a little simpler. Okay, so we have number 2 here, if you're seeing that. So same thing. So we're gonna let, can I run out? Okay, so I'll write it here, because I didn't leave much space. So we're gonna let y is equal to ln x. Ln f of x. Right, so just by comparing it, you would see that f of x is equal to x. So f dash x would be, when you differentiate this, if you differentiate x, you're going to get 1, right? So we have everything now. So dy dx would be f dash x, which is 1, over f of x in this case is x. So this one was a simple one, right? So I'm trying to do like both the simple and the more challenging ones. Alright, so we have question 3 now. Same thing, we're going to let y equal to ln f of x. Now don't let this 3 kind of confuse you, right? What we're going to do is we're going to just put like a bracket. So we're going to leave the 3 on the outside, right? So we know it's 3 times whatever going on. We're going to work out everything, and then we're just putting back the 3, or we can leave the 3, right? So alright, so we're leaving the 3. Right, so it's 3 ln f of x, right? Because we only cater with this part here. That 3 won't really make a difference. That 3 will just be there to multiply. Right, so that means that f of x is equal to square root of 2x plus 1. Now we know we can't differentiate that just so, right? So we need to just change up how it's looking. 2x plus 1. Square root is the same of power of a half. Now we can differentiate. So f dash x would be, we pull the half in front, put back what we had in the brackets, reduce this by 1. A half take away 1 is negative a half, and then we multiply by the differential of inside here. This will give you 2. We simplify. A half by 2 is 2. Remember we did this a good while ago, so if you can't remember, just go back to that video. That was the chain rule, and you'll be okay. Right, so we have everything that we need now. So dy dx would be, remember I say just put back the 3, right? Because the 3 is just, we just multiply, sorry, put back the 3 because the 3 is just multiplying, right? And then we do our thing inside the differentiation. So it's f of x on top, sorry, not f of x, f dash x, which is this here, 2 over f of x. Remember f of x was this here. We wouldn't put it like this, we put it like this because it looks a little simpler, right? So it'd be 2x plus 1. Close the brackets, right? If you want, you could open back the brackets just to, you know, neaten up things, right? With this big bracket. So you could use 3 by 2 is 6. For a negative a half over the square root of 2x plus 1, and that's it. Alright, so once you get a Ln function, just figure out what your f of x is, right? So you write it out like this here. Figure out what your f of x is, differentiate your f of x, and then just plug it into the formula and you should be okay. Right? If you guys have any questions, feel free to WhatsApp me and let me know.